Okay, this video is about Gay-Lussac's law. So this law tells us that as we increase the temperature, we also increase the pressure, assuming that our volume in moles are constant. Okay, so this is a direct relationship. So pressure 1 divided by temperature 1 should be equal to pressure 2 divided by temperature 2. Okay, so the two biggest problems that people have with these problems is, number one, they forget to convert to Kelvin. And number two, they sometimes forget to make sure that their pressure units are the same on both sides. I believe I did this in my Boyle's Law video. So if you want to go back and look at that, sometimes we'll give you two different units and you need to make sure that you convert to have the same unit. It doesn't really matter which unit you use. But in this one, I'm just going to give you a basic. Okay, so you're going to go ahead, read your problem, identify what you got here. So a closed container contains a gas at a pressure of 2.50 atmospheres at 26 degrees Celsius. What will its pressure be at 38 degrees Celsius? So I like to use the guess method. So I recommend using this on your test, your quiz, your homework, or whatever to help give you that roadmap. Okay, so we know that our first pressure was 2.50 atmospheres because that's what it told us. And that specific gas is at a temperature at that time of 26 degrees Celsius. I recommend immediately moving yourself to Kelvin before you accidentally forget about this. The way you get to Kelvin is by just adding the number 273. When I add those two numbers together, I should get 299 Kelvin. Okay, I'm going to keep reading. It says, what will its pressure be? So we're missing the second pressure. That's our unknown. At 38 degrees Celsius. So the second temperature they gave us was 38 degrees Celsius. And once again, if I'm going to want to get to Kelvin, I'm going to do that immediately. In my calculator, I just add those two numbers, and I get 311 Kelvin. So I see that I have two P's and two T's. That means I'm going to be using Gay-Lussac's law. So I'm going to say P1 divided by T1 equals P2 divided by T2. And now I can go ahead and substitute. So I'm going to put whatever I had for P1 right here, divided by my T1, which was 299 Kelvin, is equal to my P2 divided by my T2, which was 311 Kelvin. Just like in Charles' law, I need to cross multiply, or as some people call it, I need to do the butterfly method. Okay? And so, oops. I'm going to multiply whoever's in the same wing as each other. So this is going to be 299 Kelvin times P2 is equal to 2.50 atmospheres, times 311 Kelvin. And now that I have that kind of flat out like an equation, I can now solve and make sure that P2 is all alone, okay? Because we want whoever we're finding to be all alone, okay? Those guys cancel out because they're the same dude. So this becomes P2 equals whatever the calculator says this is. So when I clear that, I'm going to say, okay, 2.5 times 311 divided by 299. And this ends up becoming 2.60 atmospheres. And if I'm feeling really stressed about if I did the math right, I can go ahead and think about it conceptually. We learned that temperature and pressure have a direct relationship. So if I increased my temperature here, if I went from 26 to 38, I also should have increased my pressure. So if I started with 2.5 atmospheres and moved to 2.6 atmospheres, that means I increased my pressure, which means that I probably did my math right.